For this video, we will be just reviewing the different methods of factoring that we have learned so far. So first thing I want to make sure that we all have right now is you should have just gotten a colored piece of paper that has the flow chart on the front and then all of the steps on the back. So just to go over this really quick, this flow chart is going to be something that is extremely helpful for you today and then as we are preparing for your quiz and your test coming up for factoring. This is going to help you figure out which method of factoring you need to use. So you'll notice right here it says start here. Notice step one is always a GCF. That has never changed for any of the methods of factoring that we've done so far. So GCF, yes or no. If the answer is yes, you factor it out and then you proceed to the next question. If there's no GCF, then you just go ahead and move on to here. So then you'll notice right here the biggest questions are first, how many terms are there? So if there's two terms, are A and C perfect squares? If the answer is no, then you're done. If the answer is yes, it's special cases. And then if it's not two terms, is there three terms? Okay, if the answer is yes, are A and C perfect squares? Yes, special cases. No, does A equal 1? Yes would be simple factoring, no would be the AC method, and then last but not least, four terms. If the answer is yes, you factor by grouping. So we will go through all of these things as we do this review together, but then I also want to mention right here, factoring by grouping, all of the steps are right here. Simple factoring, all of the steps are right here. AC method, all of the steps are right here. And special cases, all of the steps are right here. So this, like I said, is going to be an extremely helpful resource for you to use as we are reviewing these methods and then as you're working on your homework or reviews coming up and things like that. So I would not lose this paper. So, like I said earlier, the whole point of this worksheet is to review all of the different methods. So you'll notice right here, it says state the method that would be best to factor the following and then state why, then actually factor it completely using that method. So looking at number one, the first thing I notice immediately is that this has multiple variables. So I know for a fact I'm probably going to be taking out a GCF here. So on number one, our method would be GCF. And then y, well, they all share something in common. So if we look at this, between 27, 36, and 18, they all share a 9 in common. That's the highest number that goes into all three of them. And then x to the 5th, x to the 8th, x to the 6th. The smallest exponent is this x to the 5th. So I know that they have to all share 5 x's in common. Remember, it's always the smallest variable. And then y to the 5th, y and y means they all share one y in common. So my reason here is they all have a 9x to the 5th y in common. So then remember, when we factor that out, the GCF doesn't just disappear. It goes out in front of our parentheses, and then inside of our parentheses is whatever's left over after you're done dividing out or factoring out that GCF. So 27 divided by 9 would be 3. X to the 5th divided by x to the 5th, those would cancel out. Y to the 5th divided by y, this is technically to the 1st, so 5 minus 1 would give us y to the 4th. And then negative 36 divided by 9 would give us minus 4. X to the 8th divided by x to the 5th, 8 minus 5 would be x to the 3rd. And then y to the 1st over y to the 1st, 1 minus 1 is 0. Those just cancel out. 18 divided by 9 would be plus 2. And then x to the 6th over x to the 5th would be 6 minus 5, which would be x to the 1st. So you can put the 1 there if you want to. I'm not going to. And then y to the 1st again over y to the 1st, those would cancel out. So then this would be our final answer. So I do want to make one thing clear. When we have multiple variables like that, most of the time we're done factoring once we have factored the GCF out, because looking at 3y to the 4th minus 4x cubed plus 2, there's nothing else I can do to factor that any further than I already have. So that would be number one. Looking at number two, if we follow that flow chart, again, step one, always look for a GCF. So on number two, 40, 25, 16, and 10, they share nothing in common as a number, as far as a number goes. Remember, 1 is not really going to help us, so I'm not going to factor out a 1 unless I have to. And then they share no variables in common. So no GCF on this one, but then if we follow the rest of the flow chart, are there 2 terms? No. So then we go to, are there 3 terms? No. So then we go to, are there 4 terms? Yes. So then the method for this one would be factoring by grouping. And the reason being on this one is the fact that it's a polynomial. meaning there are 4 terms here. So that's why we're able to factor by grouping on this one. Now, if you flip the back side of your flowchart over and look at the steps for factoring by grouping, you'll see the first bullet point says look for a GCF. We already did that. Then it says group the first 2 and the last 2 terms. So then I'm going to draw my 2 sets of parentheses. Remember, you are not cutting off this sign right here. You're making sure that we still have that minus sign in that second set of parentheses. Then it says factor the GCF out of each group. You should have the same expression in both parentheses. So the GCF for the first group would be 5x squared. So I'm going to divide both of those by 5x squared. When I do that, remember the GCF goes out in front. Whatever's left over when you're done dividing goes on the inside. So 40 divided by 5 would be 8. X cubed over x would be x. And then negative 25 divided by 5 would be minus 5. X squared on top divided by x squared, those x's cancel out. And then the GCF of the second group, remember we always follow the leading sign here, so then I'm going to factor out a negative 2 here. So then I put minus 2. That sign with the 2 is really important. You do have to have it, whether it's a plus sign or a minus sign, you do have to have that sign there. And then whatever's left over again when you're done dividing is what goes inside. So then we have 16 divided by 2, sorry, negative 16 divided by negative 2 would be a positive 8, and then the x gets brought down with it. 10 divided by negative 2 would be negative 5 or minus 5. And then like our bullet point said, our parentheses should match, and they do. So that's our first parenthesis, 8x minus 5. And then it says leaving the GCFs to be written together as one expression in the second set of parentheses. So these two GCFs get put together, 5x squared minus 2. There's our final answer. That last bullet point says be sure your answer is completely simplified. Check for any GCF that can be factored out. So again, just a reminder here, between 8x and 5, nothing else can be factored out. And between 5x squared and 2, nothing else can be factored out. So that's how I know that's my final answer. And then just another reminder, you can also check your answer by foiling this back out if you would like to. I would strongly encourage you do that on a test or a quiz. Why is this not moving on to the next slide? Okay, so then looking at number 3, which method are we going to use? So starting with our flow chart, is there a GCF, yes or no? Looking at number 3, I don't see anything that I could factor out from all 3 of those terms. So then after that, are there 2 terms? I kind of just said that. Are there 2 terms, yes or no? The answer would be no. Are there 3 terms, yes or no? The answer in this case would be yes. So then the first thing it asks you after you say yes to there being 3 terms is are A and C perfect squares? A is 1, which is a perfect square, but 35 is not a perfect square. So then I'm going to say no to that bubble. And then after that it says, does A equal 1, yes or no? Well, in this case, A does equal 1, so we are going to be using simple factoring on this one. And the reason being is because it's a trinomial, so there are 3 terms, and A equals 1. So that's what tells us that we're using simple factoring. Now, if you flip over on the back side of your flow chart, the steps for simple factoring are there. Again, step 1, bullet point number 1, look for a GCF in all terms. We talked about that. There's not one already. Draw 2 sets of parentheses and split the first term. The first term is x squared, so I'm going to split that by splitting it up into x and x. Then it says put the signs in place. If you remember, we look at the second sign first, and this says this on your steps on the back side of the flow chart. So if the second sign is positive, the signs are the same. The first sign tells you what they both are. So then I know that it's minus and minus. And then the last bullet point there says find factors of C. So if I draw my X here, find factors of C that add up to equal B. So I need factors of 35 that add up to be negative 12. So if I think about my factors, and I also know that they're both negative, so I'm going to go ahead and put that into my X. And then I need factors of 35. So 1 and 35 would not work. 2 doesn't go into 35. 3 doesn't go into 35. 4 doesn't go into 35. But 5 does. It would be 5 and 7. If I have a negative 5 and a negative 7, that would multiply to be positive 35, but add to be negative 12. So then those are the 2 numbers that I'm going to put into my parentheses here. And that is my final answer. So remember, with simple factoring, the numbers from our x's go straight into the 2 parentheses, and we are done. Simple factoring, simple steps. Quick answer, okay? Keep that in mind. Now looking at number 4, again, figuring out what method we're going to use here. Starting with a GCF, I do actually see that I can factor out a 4 from all 3 of these terms. So I have a 4 out in front, and then I'm left over with a 5x squared plus 4x minus 12. So the first method we're going to use here is a GCF because they all have a 4 in common. But then after that, I see something in standard form on the inside still. So this is different than number one. Number one was not in standard form. X's and Y's, we're not going to continue factoring that. However, this has all X's and it's in standard form. So I know I can still factor this. So looking at 5x squared plus 4x minus 12, this one has 3 terms. So if you jump to the bubble that says 3 terms, yes or no. Then we go over our a and c perfect squares, yes or no. 5 and 12 are not perfect squares, so then I would say no to that bubble. Then it says, does a equal 1, yes or no? Well, in this case, the answer is no. So then the only option I have is to then do the AC method. So then after we do GCF, we also have to do the AC method because it's a trinomial. And a does not equal 1. So this one's going to have 2 steps to it, factoring out the GCF and then factoring by the AC method. Now, if you look at the back of your flow chart, again, all the steps are there. So look for a GCF. There's not one. Find factors of a times c. So remember, in our x here, a times c goes on top. 5 times negative 12 would be negative 60. That add up to be b. And then it says, pay attention to what signs you need to be using. So again, the second sign in this case is negative. So that tells me that they're going to be different. So I know that I need, let's go with green. I need 1 positive and 1 negative number. Oops, we forgot to fill in B at the bottom. So they need to add up to 4. So then my 2 factors, 1 positive, 1 negative, is going to be a positive 10 and a negative 6. Multiply to be negative 60, add to be 4. Now remember, this is not simple factoring, so our answers are not x plus 10 and x minus 6. Remember, with these numbers now for the AC method, we are splitting up this bx term. So then I'm going to take 4x and split it up into a positive 10x and a negative 6x. And then remember, from there, we bring down a, and we bring down c, and then I'm going to keep that 4 on the outside. And then from here, we factor by grouping. So I group the first 2, I group the last 2. I'm going to factor out a 5x from the first 2. So when I do that, I have 5x out in front, x plus 2 on the inside. And then here, I'm going to factor out a negative 6. Remember, we always factor out the leading sign, so the first sign in the parentheses. And then I would put that minus 6 here. This leaves me with a positive x plus 2. My 2 parentheses match, which is a good thing. I'm going to continue bringing that 4 down. If my 2 parentheses match, that's my first parenthesis right here, and then I take the 2 GCFs that I factored out while I was grouping and I put those together. And then I bring down that final 4 out in front for my final answer. So there's a recap on factoring out a GCF at the beginning, and then as well as the AC method. We just have 2 more left to do here. Okay, looking at number 5, GCF, yes or no. I'm looking at 16, 56, and 49. They don't have anything in common. So then I'm going to go down to a trinomial, 3 terms. Are A and C perfect squares? In this case, yes. 16 and 49 are perfect squares. So this is going to be special cases. Now, if you remember from when we did the notes, if you don't like special cases, that's okay. You can also do the AC method because, again, A is not 1 in this case. So you could do the AC method if you wanted to. Special cases is extremely, extremely fast to find your answer here. So remember, we're doing this because A and C are perfect squares. So then remember, the whole point of them being perfect squares, that's good for us, we like that, is because I can take the square root of 16x squared and get 4x. I can take the square root of 49 and get 7. And then I know that I need a 4x and a 7 in both parentheses, because if you think about foiling, I know that first I need to get 16x squared. I can get that by 4x times 4x. And last, I need to be 49. I can get that by 7 times 7. And then if you check the outside and the inside, which we'll talk about in a moment, it should add up to 56x. So then last thing we need to make sure we talk about, second sign tells me that they're going to be the same. This case, they're both going to be positive, so 4x plus 7, 4x plus 7. This should be our final answer, and remember, we do have to check this just to be sure that everything works out nicely. So if I check my outside and inside multiplication, 4x times 7 would be 28x, and then 7 times 4x would be 28x. If I add both of those up, that does give me 56x. So I checked my answer, I'm good to go. Number 6 is very similar to number 5. However, no GCF again, but this one only has 2 terms, but it does say are A and C perfect squares, yes or no. Please remember that this is technically 4x squared plus 0x minus 81. So looking at this, A and C are perfect squares, so this is another special case. And then again, if you don't like special cases, that's okay. You can also do this one by the AC method. Just remember the AC method takes time. So any shortcut can really help save you time on a homework assignment, a quiz, or a test. If I take the square root of A and C, the square root of A would be 2x, depending on which one you're looking at. If you like the 0x, you can take the square root of the top one or the original problem. The square root of just 81, remember we don't care about the negative. The negative is going to help me later put my signs in place. So I know in both parentheses I need a 2x and a 9, a 2x and a 9. And then last thing here, make sure we put our signs in place. The second sign is technically what's here. That tells me that they're going to be different. So I need 1 plus, 1 minus. If I double check my answer, so let me go back to this really quick. I'm saying this is our final answer, and then if I double check, if I FOIL, but if I only focus on the outside and the inside, outside would give me negative 18x, inside gives me a positive 18x. If I add those up, I get 0x, which is exactly what I needed to happen. I needed those middle terms to cancel out. So that is it for your review of factoring all of the different methods. You have a homework assignment to work on right now, so go ahead and get started on that. And don't forget your quizzes on block day.